Hello everyone. Today we will see some practice questions from the topic physical and chemical equilibrium, and this is part 7. Let's start. Disclaimer slide which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So we will see some practice questions from question number 50 to question number 56. Let's start with the question number 50. N2 and H2 in 1:3 molar ratio are heated in a closed container having a catalyst. When the following equilibrium N2 plus 3H2 giving us 2 NH3 is attained, the total pressure is 10 atmosphere and mole fraction of NH3 is 0.6. The equilibrium constant Kp for dissociation of NH3 is. Options are 1.333 per atmosphere square, 0.75 atmosphere square, 0.75 per atmosphere square or 1.333 atmosphere square. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. So this is the reaction given in the question, that is N2 plus 3H2 giving us 2 NH3. Initially, it is given that N2 and H2 are in 1:3 molar ratio. So let's suppose N2 is 1 mole and H2 will be 3 mole and NH3 will be 0. At equilibrium, N2 will be 1 minus alpha, H2 will be 3 minus 3 alpha and NH3 will be 2 alpha. Now, if we count the total moles, it will be 1 minus alpha plus 3 minus 3 alpha plus 2 alpha, which is 4 minus 2 alpha. And the mole fraction for ammonia, it is equals to 2 alpha divided by 4 minus 2 alpha. And it is 0.6 as it is given in the question. So from this equation, we have alpha is equals to 0.75. So we can also calculate the moles of N2, which is 1 minus alpha upon the total moles. And on putting alpha, we have N2 mole fraction is equals to 1 by 10 or is equals to 0.1. Similarly, for the mole fraction of H2, the moles of H2 divided by the total moles. Putting the value of alpha, we have mole fraction of H2 is equals to 0.3. Now what we will do, we calculate the partial pressure for N2, which is mole fraction multiplied by total pressure, and it is coming out as 1 atmosphere. Similarly, for partial pressure of H2, 3 atmosphere, and similarly for partial pressure of ammonia, which is 6 atmosphere. Now, the dissociation of ammonia, if we have to calculate the dissociation constant of ammonia, right? So this is the reaction for dissociation of ammonia, which is 2NH3 dissociating into N2 plus 3 molecules of H2. Now Kp for this reaction will be product's pressure divided by reactant pressure. So P of N2 multiplied by pressure of H2 whole cube divided by pressure of NH3 whole square. So on putting values of all the partial pressures, we have Kp is equals to 27 divided by 36, which is equals to 0.75 atmosphere square. And thus, our correct option is option B, 0.75 atmosphere square. Okay, let's move to next question, question number 51. At 77 degrees Celsius and 1 atmospheric pressure, N2O4 is 70% dissociated into NO2. What will be the volume occupied by the mixture under these conditions if we start with 10 gram of N2O4? Options are 6.32 liter, 5.32 liter, 6.38 liter or 5.38 liter. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is coming out as option B. So molar mass, if we calculate for N2O4, it is equals to 92 gram per mole. and this is the dissociation of N2O4 to 2NO2. Initial moles will be the given mass upon molar mass, and the given mass of N2O4 is given as 10 gram. So 10 gram divided by 92, and NO2 will be 0 moles initially. After dissociation, the N2O4 is 70% dissociated. So it will be the total moles rest. Total moles will be 10 by 92 initial moles minus 70% of initial moles. And it is coming out as 0.033 moles. And for NO2, as N2O4 is 70% dissociated, the NO2 will be 2 into 0.076. And total moles after dissociation will be 0.033 plus 0.152. 0.152 is coming from here, and 0.076 is coming from 70% of N2O4 initial moles. So total moles is, after dissociation is coming out as 0.185. And we have given temperature, which is 77 degrees Celsius. And for converting it into Kelvin, we add it in 273 Kelvin. So it is coming out as 350 Kelvin. Now we apply the gas equation PV equals to nRT, or V is equals to nRT divided by P. We have N value, that is 0.185 moles. We have R value, that is 0.0821 liter atmosphere per Kelvin per mole. And we have T value, 350 Kelvin divided by the pressure, which is in atmosphere, that is 1 atmosphere. So volume is coming out as 5.32 liter. Thus our option B is the correct answer. Okay, let's move to next question. Question number 52. Volume of the flask in which species are transferred is double of the earlier flask. In which of the following cases equilibrium constant is affected? So we have given that the flask in which these reactions is happening right now, the volume of that flask is double of the flask in which they are present in earlier, right? So earlier flask have half of volume of present flask. So in which of the following cases equilibrium constant is affected for these reactions? Options are both 1 and 2, both 2 and 3, both 1 and 3rd, both 3rd and 4th. So we have 4 equations. N2 plus 3H2 will give you 2NH3, N2 plus O2 give you 2NO, PCl5 giving you PCl3 plus Cl2, and 2NO giving you N2NO2. These are 4 reactions, and we have to select the correct pair from the option. So you have 10 seconds to solve this question. After that, we will see that what will be the answer. Okay, so the correct answer is option C, that is both 1st and 3rd. So in case 1st and in case 3rd, del Ng is not equal to 0. If we calculate, so product side is 2 and reactant side is 3 plus 1, 4. So 2 minus 4 will be minus 2. So it is not equal to 0. In the 3rd also, product side is 2 and reactant side is 1. So 2 minus 1 will be 1. So it is also not equal to 0. But for 2nd and 4th, it is 0. Product side 2, reactant side 2, 2 minus 2, 0. Product side 2, reactant side 2, 2 minus 2, 0. But in the case of 1st and 3rd reaction, we have del Ng is not equal to 0, and thus the equilibrium constant will be affected. The equilibrium involving increase in the number of moles of gaseous components in the forward direction will be shifted forward, right? So that's why only the reaction present in 1st and 3rd will get in these reactions the equilibrium get affected. Okay, and hence our C option is the correct answer. Okay, moving to question number 53. The rate of the elementary reaction H2 plus I2 giving us 2HI at 25 degrees Celsius is given by rate is equals to 1.7 into 10 to the power minus 18 H2I2 concentration. The rate of decomposition of gaseous HI to H2 and I2 at 25 degrees Celsius is rate is equals to 2.4 into 10 to the power minus 21 into HI concentration to the whole square, right? So we have given two rates here. One for the elementary reaction H2 plus I2 giving us 2HI, and one for the decomposition reaction of HI2, H2 and I2. Equilibrium constant for the formation of 1 mole of gaseous HI from H2 and I2 is. So now we have to find out the equilibrium constant for the formation of HI from H2 and I2. Options are 708, 354, 0.0014 or 26.6. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see. So the correct answer is option D, 26.6. We have this equation for which the first rate is given. So H2 plus I2 forming 2HI, and the rate for this forward reaction is given is equal to Kf, forward rate constant, into the concentration of reactants H2 into I2, which is equals to, given in the question, 1.7 into 10 to the power minus 18 and multiplied by the H2 and I2 concentration. Next rate is given for the decomposition of gaseous HI to H2 and I2, that is 2HI giving us H2 plus I2. Now for this reaction, the backward rate constant or backward rate is equals to Kb, backward rate constant, HI square. HI is reactant, so concentration of reactant square, and it is given that it is equals to 2.4 into 10 to the power minus 21 HI concentration whole square, because 2 is in the stoichiometric coefficient of HI. So we have to find out the K for H2 plus I2 giving us 2HI at equilibrium. So for this, the Kc will be equal to Kf divided by Kb, that is forward rate constant divided by backward rate constant. And we have Kf value as 1.7 into 10 to the power minus 18 divided by 2.4 into 10 to the power minus 21, which is equals to 710. And on solving this, we have it is equals to 710, and therefore for the 1 mole of gaseous HI from H2 and I2, we have this reaction, that is half of H2 plus half of I2 giving us HI. Now for this reaction, the Kc will be this reaction's Kc to the divided by 2. If we divide this reaction by 2, we will get this reaction, final reaction. So its Kc will get square, under square, right? Square root. So the Kc for the final reaction will be equals to under root of this reaction rate constant. So under root of 710, and this will be equal to 26.6. And hence our correct answer will be option D, that is 26.6, right? Okay, let's move to our next question, question number 54. In the reaction AB giving us A plus B at 30 degrees Celsius, Kp for the dissociation equilibrium is 2.56 into 10 to the power minus 2 atmosphere. If the total pressure at equilibrium is 1 atmosphere, then the percentage dissociation of AB is. So options are 43.5%, 13%, 87% or 16%. So we have given the Kp for the dissociation equilibrium, and we have given the total pressure, and we have to find out the percent dissociation of AB. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D, that is 16%. So this is the reaction, dissociation reaction given in the question, that is AB giving us A plus B. Initially, A is 1 mole AB is 1 mole, A is 0, B is 0. And at equilibrium, AB will be 1 minus alpha, A will be alpha, and B will also be alpha. So if we find out the partial pressures for A, B, and AB, it is for A, the number of moles at equilibrium, that is alpha upon 1 plus alpha total moles into the total pressure P, let's suppose. And for B, alpha upon 1 plus alpha into P. For AB, it is 1 minus alpha upon 1 plus alpha into P, right? And Kp, you can say, is the pressure of products divided by pressure of reactants. So we have pressure of products as P and Pb. So on combining these, we have P alpha square upon the reactant partial pressure, which is this 1 minus alpha upon 1 plus alpha, and on solving that, Kp is equals to P alpha square upon 1 minus alpha square. So you just put Kp equals to the partial pressures for Pa and the partial pressure for B, multiply them and divide them by the partial pressure of AB and solve them, and after that the Kp will be equal to, finally it will be equal to P alpha square upon 1 minus alpha square. Okay, and we have given Kp in the question, that is 2.56 into 10 to the power minus 2 atmosphere. So Kp will be equal to 2.56 into 10 to the power minus 2 atmosphere. And now the P, we put P as 1. So alpha square into 1 atmosphere upon 1 minus alpha square is equals to 2.56 into 10 to the power minus 2 atmosphere. And we assume here that 1 minus alpha is equivalent to 1 because on seeing the Kp value is small. So we just assume 1 minus alpha is equivalent to 1. And so the alpha will become 0.16 on solving this equation. On solving this equation, the alpha will become 0.16 or 16%. So 0.16 or 16%. And thus our correct option will be 16%. Okay. Okay, let's move to next question. Question number 55. The rate of elementary gaseous phase reaction 2NO plus O2 giving us 2NO2 at 380 degrees Celsius is given by rate is equals to 2.6 into 10 to the power 3 NO whole square O2 concentration. The rate of reverse reaction at same temperature 380 degrees Celsius is given by rate equals to 4.1 into NO2 whole square. Hence, equilibrium constant for the formation of NO2 by chemical equation this is. So we have this equation NO plus half of O2 and we are forming NO2. And we have to find out the equilibrium constant for this reaction. Options are 6.34 into 10 to the power 2, 1.577 into 10 to the power minus 3, 25.18 or 3.97 into 10 to the power minus 2. So you have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, let's see. So the correct answer is option C, that is 25.18. So we have given the forward rate, that is Kf into NO concentration whole square into O2 concentration. And the rate of backward reaction will be Kb into NO2 concentration whole square. We just we just write it by looking at this reaction given in the question. Now what we will do, at equilibrium, we know that Kc will be equal to Kf divided by Kb, which is nothing but NO2 whole square upon NO whole square divided into O2. And we just put the value of Kf and Kb, which is equals to 2.6 into 10 to the power 3 divided by 4.1, and it is equals to Kc. Now, if we want to write the Kc for this reaction, which is asking in the question, that is NO plus half O2 will give us NO2. The Kc for this reaction, let's suppose it is K prime C, will be equal to under root of the Kc for the initial reaction, right? Because we have this initial reaction in this form. So if we divide it by half, if we divide it by 2, so this 2NO will become NO, O2 will become half of O2, and 2NO2 will become NO2, right? So we just write the Kc for this equation, and we just write the Kc for this equation, and this final equation Kc will be equal to Kc for this reaction to the power 1 by 2, because we are dividing it by 2. So power in power it will come, right? So it will become under root of Kc, and it is coming out as 25.18. Okay, so final Kc value for this reaction is coming out as 25.18, and thus our correct option is option C, that is 25.18. Okay, let's move to our next question. Question number 56. When NH3 is heated in a 0.5 liter flask at 700 Kelvin and 100 atmosphere pressure, it decomposes into N2 and H2, and their equilibrium moles are given below. So this is the reaction, 2NH3 giving us N2 and 3H2, and these are the equilibrium moles which is given to us. So at equilibrium NH3 is 0.3, at equilibrium N2 is 0.3, and at equilibrium H2 is 0.9. So which of the pairs given represents correct value? We have to find out. For what? For initial moles of NH3 and Kc for NH3 formation. So we have to find out these two things, and we just pair it up, and we have to match it with the option and choose the correct one. Options are 0.8 or 9.72, 0.9 or 9.72, 0.8 or 0.103, 0.9 or 0.103. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see. So the correct answer is option D, that is 0.90 and 0.103. So this is the reaction given in the question. 2NH3 will give us N2 and 3H2. Initially, let NH3 is A mole, N2 is 0 and H2 is 0. At equilibrium, NH3 will become A minus 2x, N2 will become x, and H2 will become 3x. Now, as we have given that at equilibrium, the moles are this, and this for NH3, N2, and H2. So N2 is 0.3 moles at equilibrium, and we can see that at equilibrium N2 is x moles. So x will be equal to 0.3. Therefore, we can write that A minus 2x will be equal to 0.3 as given. And from this equation, we have A is equals to 0.9. Thus, the initial moles of NH3 is 0.90 moles, right? So first thing which we have to find out has come. So now Kc for NH3 formation, and for this we will write the Kc for the equation, which is the product concentration and divide by the reactant concentration. So N2 into H2 to the whole power 3 divided by NH3 square. Now N2 concentration will be given moles, which is 0.3 upon the volume, which is 0.5. Similarly for H2, 0.9 upon 0.5 whole cube. Similarly for NH3, 0.3 divided by 0.5 whole square. And now on solving this, we have Kc is equals to 9.72. So we have our second value also, that is the Kc for NH3 formation. So for NH3 formation, this Kc we have find out for this equation, right? In this equation, the NH3 is dissociating, but we have to find out the Kc for NH3 formation. And now we have Kc is equals to 9.72, and we just have to find out the Kc for NH3 formation. So for the NH3 formation, we just reverse the initial reaction, and initial reaction is given as 2NH3 will give you N2 plus 3H2. So just we reverse it. So NH3 will come at right hand side. So the formation of NH3 will, the reaction of formation of NH3 will become equal to N2 plus 3H2 will give you 2NH3. So we just reverse this. So on reversing, its rate constant will also change, right? So the final Kc for NH3 formation reaction will be 1 upon the rate constant for initial reaction, which is 9.72, and hence it will be equal to 0.103. So we have both values in the pairs, which is initial moles of NH3 and Kc for NH3 formation, and thus our D option is the correct one, 0.9, 0.103. Okay.
Okay.
Thank you.